Hi everyone, I am Dr. P. Kumari, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering. Today I am going to discuss about the Newton's law of cooling and what is the Newton's law of cooling and how to solve the problems by using Newton's law of cooling. These are the contents we are going to discuss in this video. So see here. So what is the statement of the Newton's law of cooling? We can observe here. The rate of change of the temperature of a body is proportional to the difference of the temperature of the body and that of the surrounding medium. So what is the meaning of the rate of change of temperature? Means here if you are taking the temperature is theta. So rate of change. So we are taking this one with respect to time. So rate of change, that is d by dt of theta. This is proportional to difference of the temperature of the body. If you are taking temperature of the body is theta and surrounding temperature, we take it as theta naught, that difference. That means theta minus theta naught. So this is the difference of the temperature of the body and that of the surrounding medium. So rate of change of temperature is proportional to difference of the temperature of the body and that of the surrounding medium. So here we are taking theta with the temperature at time t and theta naught with the temperature of the surrounding medium. So maximum we will take air only. So we can observe in the figure. So here this is the temperature of the surrounding. So we can call it as ambient temperature also. And here at the initial state, what is the temperature of this body? And at the beginning means there is no time, right? We will take t equal to 0. So at initially temperature of the body, how much? So after some time, what is the temperature of the after some time means there may be 10 minutes or 20 minutes or 30 minutes. That depends on the given problem. So after some time, what is the temperature of the body? So by using these two conditions, we are going to calculate the temperature of the body at the given time. So already we discussed about how we are getting the temperature of the body equation for the differential equation. So here this all derivation part we done in the previous video. If you want, please go to that video for the derivation part of the temperature of the body. You can observe here theta equal to theta naught plus 1 minus theta naught into e power minus kt. Otherwise, theta equal to theta naught plus e into e power minus kt. This is the final equation of the temperature of the body at time t. So this is the equation we are going to use to solve the given problems. So first of all, how to solve the given problems? How many types of problems will be there? So here, this is the working rule for the given problem. So for every problem, what is the procedure or what is the working rule we are going to observe here? So here, this is first one, we have to identify the surrounding temperature. That maximum we will take as a theta naught. So first we have to identify the surrounding temperature from the given problem. In the second step, we have to calculate C value from the condition. That is, what is that condition? Temperature of the body at t equal to 0. So here first condition we can observe temperature of the body at t equal to 0. From this condition we are going to calculate the C value. So in the third step we are going to calculate K value from the condition. What is that condition? Temperature after some time. So what is the temperature of the body at t equal to after some time? They may give 10 minutes also, 20 minutes also, otherwise 30 minutes also, whatever it may be. So after some time, what is the temperature of the body? By using this second condition, we are going to calculate the K value. So next, fourth one. So what they are asking to calculate? If they are asking to calculate the temperature, we can calculate the temperature or time. So they can ask the temperature at some time. They will give the time also. Otherwise, we have to calculate the time for the temperature what they given. So these two type of problems we are going to get. So here two types of problems will be there. First, we have to calculate the temperature of the body for the given time. First, we have to calculate the temperature of the body for the given time. Next, we have to calculate the time for given temperature for given temperature. Sometimes they may ask to calculate the temperature and time also. So these type of three problems we are going to get in the Newton's law of cooling. So this is the working rule or procedure we are going to follow to solve the given problem by using the Newton's law of cooling. So we can observe the example here, how we can observe for the Newton's law of cooling. So just we are taking one cup of coffee. So here we are observing the surrounding temperature. They are given 25 degrees C. So at the surrounding temperature, so at starting, that means initially T equal to 0. So what is the temperature of the coffee? So that is the first condition. So after some time means after some time, that given time for the tea or that is 10 minutes also, 20 minutes also or 30 minutes also, whatever it may be, we are taking after some time, what is the temperature of the coffee. So these are the two conditions we are going to use. And what is the temperature of the coffee after some given time otherwise. So after 30 minutes, what is the temperature of the coffee? Like that they can ask the question here. So otherwise you can see this example. So here we are taking one cold drink or juice. So here surrounding temperature we are considering as 25 degrees C. So at the initially what is the temperature of the juice or of this bottle. So after 10 minutes or after 20 minutes, what is the temperature of the juice? So if you are taking temperature is 65 degrees or 55 degrees, so what is the time taken? So like this they can ask the questions. So these are the two examples we can observe generally in our surroundings. So just I am moving with the example problem now. We can observe here. Here the given problem is a body kept in air. So already I discussed now the surrounding temperature usually we will consider the air only. So a body kept in air with the temperature 25 degrees C cools from 140 degrees C to 80 degrees C in 20 minutes. Find when the body cools down in 35 degrees to 35 degrees. So here a body kept in air. So that means surrounding temperature. What is the surrounding temperature? Surrounding temperature theta naught. We are taking theta naught is 25 degrees C. Okay. After that, so first we have to analyze the data. So then it is easy for you to calculate the problem. What is the given data? What we are going to calculate. So observe here the surrounding temperature I am collecting from the given data, that is theta naught equal to 25 degrees C. So here cools from 140 degrees C to 80 degrees C. So it is cooling from 140 to 80 degrees means what is the initial temperature? Starting temperature is 140 degrees C. That means temperature is 140 degrees at initially means time is 0. So at t equal to 0, theta value, otherwise temperature is 140 degrees C. It is cools from 140 to 80. So it cools from 140 to 80, going to 80 in 20 minutes. That means temperature is 80 degrees C at t equal to 20 minutes. Theta equal to 80 degrees C at t equal to 20 minutes. This is the given data from the problem. So we know the surrounding temperature theta naught value. So first condition is there. We can calculate C value from the first condition. Second condition also is there. We can calculate the K value from the second condition. So this is the given data. What we have to find? So find when the body cools down to 35 degrees. That means, so we have to find the time. For what time it going to get the 35 degrees C. So for the temperature 35 degrees C, what is the time we are going to calculate? So here, according to the procedure, first we have to identify the theta naught. So according to the working rule. So already we identified the theta naught. So first we are writing the given data. So given data is the temperature of the surrounding temperature theta naught is 25 degrees C. And theta equal to 140 degrees at t equal to 0, and theta is 80 degrees at t equal to 20 minutes. Now, by the Newton's law of cooling, what is the statement? T theta by dt equal to minus k into theta minus theta naught. So, according to this step, finally we can write theta equal to theta naught plus c into e power minus kt. This is the equation. This is the equation of the Newton's law of cooling. So from this equation we are going to calculate. See here, if you know the C value, if you know the K value, then only you can calculate theta value, right? So already we know the theta naught from the given problem, and we have to know about the K and C. So then we can calculate the temperature. That's why from the first condition we are going to calculate C value. From the second condition we are going to calculate K value. So first of all, I am taking the first condition. Here theta naught value is 25 degrees C. And here first condition is theta equal to 140 degrees C at t equal to 0. This one I am going to substitute in the equation 1. So theta equal to, what is the theta naught? 25 degrees plus C into e power minus k into t is 0. So what is the theta value? So this is 140. So 140 equal to 25 plus c into e power 0 is 1. So finally c equal to 140 minus 25. C equal to 140 minus 25. What is the final value? 140 minus 25 is 10 minus 5 is 5 here. 3 minus 3 is 1. So 115. So C value is 115. C value is 115. We got the C value from the first condition. So first step in the working rule, first step is identifying the theta naught, that is completed, and second step we calculated C, that is also completed. We are moving to third step. What is the third step? So theta equal to 80 degrees C when t equal to 20. This is the second condition. This one we are going to apply in the equation 1 to get the k value. So third step is to calculate k value, right? So theta equal to theta naught plus c into e power minus kt. So here theta is 80 equal to theta naught is 25 plus C value is 115 into e power minus k into t is 20. So now 80 minus 25 is equal to 115 into e power minus 20k. So 80 minus 25 is how much? So 80 minus 20 is 60, 60 minus 5 is 55. So 55 equal to 115 into e power minus 20k. So finally minus here e power minus 20k is equal to 55 by 115. 55 by 115. So now I want the k value. So k equal to here minus 20k equal to log. So when I am sending exponential to the right hand side, I am getting here log. So log 555 by 115. So finally k equal to minus 1 by 20 log 55 by 115. This is the value of k. So you can simplify this value by using the logarithmic value from the calculator. So otherwise keep it as it is. After then you can simplify. So we calculated k value also. That means third step also completed. So now what we have to do, what they are asking to calculate, we have to calculate the time for the temperature theta equal to 35 degrees C. That is we are going to do now. So here we have to calculate the time for the temperature theta equal to 35 degrees C. So already we know the theta naught value. What is the theta naught value? Theta naught equal to 25. We know the C value. What is the C value? 115. What is the K value? K equal to minus 1 by 20 log 55 by 115. So already we know all these terms. We can calculate the time here. So theta equal to theta naught plus C into e power minus kt. So theta value we are going to calculate. So theta naught is 25 plus C value is 115. So here e power minus. So minus into minus plus. So 1 by 20 log 55 by 115 into t. So t we are going to calculate. So now this I can write it as 25 plus 115 into e power t by 20 log 55 by 115. So theta equal to 25 plus 115. This one is here I can take it as log e base c. This I can send to power. So 55 by 115 whole power t by 20. So from this simplification, so what is the theta value? Theta value is 35. So 35 equal to 25 plus 115. So 55 by 115 power t by 20. So 35 minus 25 equal to 115 into 55 by 115 power t by 20. So 35 minus 25 is 10. So here 10 by 115 is equal to 55 115 power t by 20. So when you are simplifying this equation, so t by 20 we are getting here. So when you are applying the log, we are getting the value. So log of 115 by, so log of 22 by 11. So when you are simplifying this value by using the calculator, so we are getting here 3.31. So finally here time equal to 20 into 3.31, that is finally 66.2. So for the temperature theta equal to 35 degrees C, we are getting the T value is 66.2 minutes. So here to calculate this value, we compulsory need calculator to get the logarithmic values. So how to use the logarithmic value also very important. Here two types of logarithmic value is there. Log 10 value also is there, and natural logarithm, nothing but log e base c. So this is also is there. So don't use the logarithmic 10 values. We have to use the natural logarithm, because here we are using natural logarithm only. So if you are taking log 10 value, that value will be different. So that's why don't take log 10 value. Take the natural logarithmic value. So that value only correct value to calculate the temperature or time for the Newton's law of cooling. Okay. Is it clear? I am moving with one more example here. The temperature of the body drops from 100 degrees C to 75 degrees C in 10 minutes. When the surrounding air is at 20 degrees C temperature, what will be its temperature after half an hour? When will the temperature be 25 degrees C? So before they asked only temperature. Now here two types of questions they are asking here. First of all, write down the given data. So what is the given data? First step from the working rule, we have to identify the surrounding temperature. So the temperature of the air, that is 20 degrees C. And so temperature of the body drops from 100 to 75. So that means what is the initial temperature? Initial temperature is 100 degrees C, and at T equal to 0. So it is cools down to 75 degrees C after 10 minutes. That means T equal to 10 minutes. This is the given data. So what we have to find? Here two values we have to find. First one is what will be its temperature. So what will be its temperature after an half an hour. So that means at t equal to half an hour means 30 minutes you can write. And second question also is there. We have to calculate here time for the temperature theta equal to 25 degrees C. So here they are asking to calculate temperature and time both. So first of all, we are writing the given data. Surrounding temperature is theta naught equal to 20 degrees C, and for the given condition theta equal to 100 degrees C at t equal to 0, and here theta equal to 75 degrees C at t equal to 10. So from the first condition we are going to calculate C. From the second condition we are going to calculate K value as like a previous problem. So first, what is our condition or what is our differential equation? By the Newton's law of cooling. By Newton's law of cooling, theta equal to theta naught plus C into e power minus kt. This is the equation. So here theta equal to surrounding temperature is 20. So 20 plus C into e power minus kt. So this is the equation we are going to use to calculate the values here. So first I am using the first condition. So when t equal to 0, theta is 100. So then theta equal to 100, right? I am substituting here 100 equal to 20 plus C into e power t is 0. So e power 0 is 1. So finally C equal to 100 minus 20. So finally this is 80. So this is only C value. So here, so we calculate the C from the first condition. Now we are going to calculate the K from the second condition. What the second condition? When t equal to 10, theta is 75. So 75 equal to 20 plus C value is 80 e power minus k into t is 10 minutes. So 75 minus 20 is 55 equal to 80 into e power minus 10k. Now 55 by 80 is equal to e power minus 10k. So finally minus 10k equal to log 55 by 80. So what is the k value? K value equal to minus 1 by 10 log 55 by 80. This is the k value. So from the second condition we calculate k value also. So here otherwise you keep it as it is for the e power minus 10k equal to 11 by 16. Otherwise you can take k equal to minus 1 by 10 log 55 by 80. So when you are using the calculator we can write the final value also. So here, so up to now we calculated C and K. So we have to calculate the next one we have to calculate the temperature and time also for the given problem. So first step we have to calculate theta value at t equal to 30 minutes. At t equal to 30 minutes. Already we know the theta naught is 20, C value is 80 and k value is minus 1 by 10 log 55 by 80. Otherwise, we can use e power minus 10k equal to 11 by 16 also. So here, first of all, theta equal to, what is the theta? We have to calculate, right? So theta naught plus c into e power minus kt. So here theta naught is 20 plus c value is 80 e power minus k into for the 30 minutes, right? So k value is, t value is 30. So now 20 plus 80 into, we can replace the k value also. So here minus plus, so 1 by 10 log 55 by 80 and 30 also is there. So 30 by 10. So this becomes 20 plus 80 into here e power 3. That means log 55 by 80 whole cube I can write. So now 20 plus 80 into log e base c. So 55 by 80 whole cube. So when you are simplifying this value, we are getting the theta value is 46 degrees C. Theta value is 40 degrees C. So this calculation we can do by using the calculator. So calculators are allowed for the exam. Okay, because we are having logarithmic values, right? So theta value is completed. So in the second step, what they are asking to calculate the time for the temperature 25. So here in the same way, so here what is the temperature they are giving? Temperature for the temperature 25 degrees C. We have to calculate the time. So here temperature is 25 and theta naught is 20 plus C value is 80 and here E power K value is minus 10, so 1 by 10 log 55 by 80 into T. So in the same way we can simplify this. 25 minus 20 is 5 equal to 80 into E power. So this is T by 10 log 55 by 80. So here this becomes 5 by 80 equal to, so here log and base E, this is 1, log E base is 1, so 55 by 80 power T by 10. So when you are applying the log here, we can get the value. So finally, what is the T value we are getting here? 74.86. So this is only value we calculated. So log 5 minus log 80 by log 11 minus log 16, otherwise log 55 minus log 80, both are same. When you are simplifying that, we are going to get 11 and 16 only. So now finally simplification. After simplification, we got the value 74.86 minutes. So this is the time for the temperature theta equal to 25 degrees C. So I hope you get the better clarity about the problems on Newton's law of cooling. For the more problems, you can go through these references. That is Higher Engineering Mathematics written by B.S. Gravel and a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal, and Higher Engineering Mathematics written by B.V. Ramana, and one more textbook also you can use, Engineering Mathematics written by T.K.V. Iyengar as John Publications. For the basic problems and for the more examples, you can go through these textbooks. Please practice more and go through the examples more. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.